In this video, we're going to be talking about like terms and how to add and subtract polynomials. So the first thing we need to talk about are the like terms themselves. Like terms have the same variable raised to the same exponent. So here I see p squared, p squared. It doesn't matter that there's an 8 here and a negative 2. These are like because I have the same letter, the same variable, raised to the same exponent. I could have also q cubed, or jk, or just constants themselves, so no variable. These are like terms. Even if there's more than one letter, this has jk, right? They're all like. The variables and the exponents are the same. Things that are not like would be, even though I have the same letter here, this is y squared and this is y. These are not like terms. This is like something one-dimensional and something two-dimensional. Can I add 3 feet to 3 square feet? No, they're not like. And of course, different variables are not like as well. The way we add like terms is you add and subtract the coefficient, and then the variable has to stay the same. So on this first example here, we have this polynomial 4x squared y minus x squared xy squared plus 5 plus this other polynomial negative 6x squared y minus 1. So when we're adding, we can add in any order we want. So these variables, or these parentheses, don't really add anything to our problem. I can add and rearrange these in any order I want. So I'm going to look strictly for the like terms. I see a 4x squared y here, and a negative 6x squared y. This is not like because it's x and then y squared, versus this is x squared and then y. So these are not like terms with the other two. But I also see a constant and a constant. And I can add these like terms. So starting with the coefficients for the first one here, I have 4x squared y minus 6x squared y. So 4 minus 6 gives me negative 2x squared y. The variable part stayed the same. And then I would write the next term, minus xy squared. There's nothing to combine that with. And then 5 plus a negative 1 would be positive 4. And now nothing else is like. That's as far as I can go. Let's do one with subtraction. Now subtraction is not commutative, meaning it does matter the order. And in this case, I am subtracting this whole polynomial on the right. So everything in there has to get subtracted. Every single term has to be subtracted. So I'm going to do that by distributing a negative 1. Right? There's like this imaginary 1 here. And I will distribute it into the parentheses to make sure everything is getting subtracted. This first parenthesis stays the same. There's no negatives outside. This is exactly like it was. Then, negative 1 times 9 is negative 9x to the 4th. Negative 1 times x squared is negative x squared. And negative 1 times negative 18 is a positive 18. And then again, I look for like terms. And you may also see the terminology descending order. That means I'm going to start with the highest degree and go down to the lowest degree. So I'm going to start with these x to the 4ths here. That's my highest degree that I see. Then I'm going to go on to the x squareds. That's the next highest degree that I see. And then I have an x and a constant. Those are different. And I just like to use this little boxes and circles and lines and squiggles and triangles so I can visually distinguish my like terms. So the box gets added to the box and the circle gets added to the circle. You don't have to do it that way. You could also rearrange them to put the x to the fourths next to each other, or you could just leave it as is, as long as you can identify the like terms that need to be added. So in this case, 7x to the fourth minus 9x to the fourth. 7 minus 9 is negative 2. The variable stays the same. Don't try adding these exponents together. Then I have negative 8x squared minus 1x squared. I get negative 9x squared. And then last I have my x term and my constant. They do not have any like terms to add. Alright, go ahead and try the next two examples and see how you do. Alright, in this next example, I am subtracting, so I have to be sure to distribute a negative 1. The negative 1 is going to go to every term inside my parenthesis here. And the first one stays the same. So I have 7a squared b cubed minus ab squared. And then negative 1 times 3 would be negative 3a squared b cubed. And negative 1 times a negative 4 is positive 4ab squared. And negative 1 times a positive 6 would be negative 6a. Again, I'm going to look for those like terms, and I like to group them visually. So I'm going to put, let's see, a squared b cubed, a squared b cubed. Those are like. Then I have an ab squared, and an ab squared. And then my a, single a, is all by itself. So now I go to add these like terms. So I have here a 7 minus 3 will give me 4a squared b cubed. Negative ab squared, positive 4ab squared. So 4 minus 1 would be 3. B squared, variable stays the same. And then I had my minus 6a at the end. So again, that highest degree down to the lowest degree is called descending order. And the last one here is all addition, so the addition of this polynomial to that polynomial. I just have to look for my like terms. So I have a negative 6ab and 12ab. I have a 2a and an a. So this is going to be negative 6 plus 12 is positive 6ab. Positive 2a minus 1a is just a. You could also write 1a here, but I think your homework would prefer you don't. This is considered more simplified to not write the 1. I don't need a 1 here, so I'm not going to write it.